Hi folks, let's take this chunk of aluminum and turn it into this heat sink. We're going to use a 4-inch slitting saw, actually I think it's called a side milling cutter, and this 1/8 inch Lakeshore carbide end mill to do the majority of the work. Let's do this whole job soup to nuts though on video. Welcome to another Wednesday widget. So this was a customer job and they need a custom heatsink made. You know, don't ask questions. When we first ran the sim, I thought, well, if I can't get the slitting saws to work, I want to see, will it work with an adaptive strategy where you're doing everything with a 1/8 inch end mill. I have no doubt we could get that to work. The problem is, you look at the machining time, it's something like 11 hours. It's just not fun to do, and the bottom of this slot is just under 160, so a 3/16 tool wouldn't work, and 1/8 inch starts to get a little bit more fragile. And so if you guys followed our Instagram, we were posting a bunch of testing photos or videos of trying to use these slitting saws. They're not like, it's funny, they're not that hard to get to use, but they're easy to screw up. So I have a whole box of these things, and you can buy these things for pretty darn inexpensive, which is really funny because even though they're commonly seen on horizontal mills, you can use them on arbors like this one from Tormach easily. And if you want to get fancy and cute, you can even stack them up and do custom spacing and diameters and so forth. So I couldn't find my box during the move, and I bought this one. So this is a slitting saw. And the difference is this one doesn't cut on either side here, whereas this one, which is what we're going to use because I finally found my box, it does. There's a card here to Tom Lipton's video on slitting saws, which was great. We certainly learned a lot. We're going to conventional it, and we're going to do it in one depth of cut, but we're getting ahead of ourselves. First thing I need to do is we're going to take this piece of aluminum, 1-inch 6061 by 6 by 4, and we've got to cut it to size. It's going to make the job a little easier, and so it's 5.44 by 3.99, and if we click the top face and the bottom face, by 984. So let's head over to the Tormach and do that first. We've got a lot of extra room on the length and the thickness, but it's this width here. The part is measuring about 1/8 thou over 4 inches, so I've only got 1/9 thou there. I've only got a little bit to clean up. So let's see if we can hit that. Okay, a little bit of noise, a little bit there. So I'm actually going to hang the part off just as hair to the side. We've got a bunch of fog busters. This is the only one that drips coolant. I gotta figure out why it's doing that. So 2,000 RPMs, and let's just jog down in thou increments until we start scratching. Okay, there's a scratch. Okay, I'm all the way across. Stop. Back off. I'm gonna 0, and I'll come down 2 thou. Let's see if that cleans up that face. Just jogging at 14% in Path Pilot here. Even go faster. Awesome. How much did we take? Woo! 4.002. That's gonna cut it close. That was pre-thou below my prior Z. Yeah, we're not touching. Just betrayed my own tram right there. I gotta tram that machine in now that we're here, but we're close. Like 2 more. There we go. Let's measure this. I suspect the critical tolerances on this thing are the footprint and the hole locations. A few thousandths though is I think going to be okay. So, that's funny. I must have had a poor measurement before. Granted, these are relatively inexpensive micrometer or calipers, but I'm actually getting 4. So that's awesome. We're going to be okay. Yeah, I'm actually just going to leave it at that. How tall is my part? About. I think it was about 6 inches, approximately. Yeah, 6.03. We need 5.44. So we'll rough this out here. Just say that's 0 on this tool. And we'll come down. Actually, well, you know what we'll do? We'll say that's 6. And now I'll just jog down 5.5 or so. 2,500 RPMs. We'll jog at 20%. This is a this is from Meritool. Although Carl from Lakeshore just sent me a tool here to test, which I'm super excited about. Seeing how it performs. So more to come on that. We generally have replaced this tool with the shear hog because that's about a $50 tool, and if you break a corner it chips and it's not as rigid, and we love the shear hog, but there are times when this tool is super useful and it gives a great floor finish. Let's see how she does here. It's 2,500. We'll just jog at 15% in Path Pilot. It is a great floor finish, but no reason not to make it a little better. Okay. Give this a quick edge break here. Stick in our Heimer. Jog down, find the base of this vise, and say that is negative 5.44. Just jog down. I'll leave 10 thou clean up. We'll go 1700 RPM this time. Cool it forward. If we wanted to stiffen this up more, it's right on the verge. It probably wouldn't hurt. I would just take a 246 block and smack it in between, sandwich it, or even just one of them would help a ton. Doesn't even really add any time to your setup. And then if that's not good, you could take those and you could put a cant twist clamp and sandwich it and clamp it up higher as well. So there should be 10 thou left to clean up. So when my tools were all measured correctly, and that's the nice thing about doing this is we can just take our part out and give it a quick test. It should be 5.54. Oops. Well, that's lucky. 5.446. Make sure. Oh, you know, I could have had a chip in there. Okay. So I jogged down to see here positive 0.4 because we only need to come down 6 thou and we were 10 thou high. Forward. Trying to use less air near my machine. Nothing good comes from blowing air all throughout the interior of the machine. Five point 5.4395, 5.44. So within a thou or half a thou, if you believe these. Perfect. So we've got, let's see here, 984, quite a bit to clean up there. So I'm just going to take, again, as little as I can. See if that gets us. Yep, that's actually leaves us at 1 inch. The extrusion is usually a little oversized. 998, 999, perfect. So we were at 999.999 in PathPilot, so if I just jog down to 984, we should be good to go. My mill has a little bit of tram issue going the other way, so this will be the bottom. We'll come this way on it, and we should get a even more perfect floor. I gotta fix my mill. It's actually not a big deal to do. One of the things I've noticed with the superflies, you can go faster. It doesn't seem to really bother it. Okay, we're about a thou off, which is fine. 985, 984 and a half. So now that we've got our stock to size, what I like is it makes this next stop pretty easy. We'll set our origin in the top left corner. We'll do an adaptive with a shear hog here to rough out the two sides. Clean up the floor with that rougher that does actually leave a great job on the floor finish. Use a 1/4 inch mill to clean up the two side walls, these guys right here, and then spot and drill those 4 corners. A couple of quick notes on I'll post the speeds and feeds when the tool's running on our adaptive. We leave side wall and floor finish on our adaptive for cleanup. On the horizontal, so horizontal is an operation that goes around and looks for flat areas and cleans those up. So we're gonna leave some sidewall when we do the horizontal, because when that rougher comes around, if I show you here on the CAD side, that rougher is gonna clean up this floor. I don't want the side of that rougher to touch this wall, especially because it's a rougher. That corncob would actually mess up our sidewall. But even if it were a finish end mill, I only want it to be focused on the floor. So back in CAM, if you take a look here on the horizontal, if I right click, edit, under the 4th tab, passes, you can see stock to leave, 6 thou radial. So it's gonna stay 6 thou away from the side wall, which is fine, or it's what we want. And when I come in with the 2D the contour to clean up this side wall, I'm actually gonna stay 1 thou off the bottom, because I only want that tool 31 to be focused on the sidewall. No need for it to touch the floor. So not in theory, in practice, if you had a optical comparator or some microscope, you could look and there'd be a tiny 1 thou, stair step or something in the corner there. Not a big deal. Doesn't matter at all. And yeah, let's go make some chips. Grabbed a set of parallels, which should leave 1/8 of an inch. So one of the things that I think that people don't realize is you can use the distance between here and here on calipers to measure. So if I stick that, and just come down here, sure enough, you know, 126, 125. Plenty of one smack with a hammer. Parallels are seated. Our Heimer. That's our X. I love the touchscreen. It helps me move quickly, and if the cameras weren't in the way, it'd be even faster. There's our Y0. That's actually good to see. We were already zeroed on our back jaw within half a thou. And tool 99 is our Heimer, which only matters now for the height. Z0. Continuous, just sweep that part and you can see we're good. Almost no variation across that whole part. Awesome. Shear hog. Rock and roll. Get a lot of questions about why we don't have a tool changer on this machine, and you know, I'd like to have one, but I also just don't need it. You just saw how quickly I changed the tool there. It's not. Yeah, that's the cam, dude. Way too slow. It doesn't. You know, it's money. It's, you know, $3,000 or $4,000, I think, and this is, you know, we have one on the other machine. This is kind of my prototype machine. And a lot of times if we're doing something higher quantity, I'll just say, here, see, it's staying 6 thou off the sidewall there, which I think is cool. You know, if I have to do a batch of 10 or 20 parts, sometimes I'll just set the retract height a little bit lower, which even saves that time you just saw right there. I mean, hey, money were no object, I'd buy one. We love it on the other machine. You can see these chips coming off. They are long, thin, pointed. Yeah, there you go. The long, thin, there you go, chip that's going at full depth of cut, very, very, very thin radial cut. Should, knock on wood, give us a darn nice surface finish. And again, we're staying 1 thou, if I measure correctly, we're staying 1 thou off the floor, which prevents you from having that toolpath mark along the bottom surface there. I read a PDF or a PowerPoint from Boeing, which is where on machining strategies, which is where I picked that up. Be curious to see if anyone else sort of believes it. It makes sense to me though. The idea is you're only asking the tool to cut on the side or the bottom, not both at the same time. Deflection is real. I don't care what quality or capability of a machine you have or what tool you have, everything deflects. So now we got to slot it. Let's take a look at the cam first and then we'll talk about the setup. So, slitting saw. I've got the y-axis going this way and we're gonna want it, let's see, if we're looking at the machine, I want to see the part like this. Right now it's like this. So all we've got to do to fix that is right click on the setup, edit, and x-axis. Instead of it being the work axis, I'll click on work axis there and I'll pick that line. That's fine, it's now correct, but it moved the point on me, so I'll change it. I actually don't want it to be a stock box point. It's probably one and the same here, but I don't want to ever risk it. I'm going to change it to model box point. I'll pick right here. That's weird. A little glitchy. See, it doesn't do that, so I'll pick one point over here and then pick here. Why don't you want to go there? Maybe a selected point? Huh. Just, you know, triple check that that's the right origin. Okay. And we got the body selected. Okay. So how are we going to do this? So here's the big question is, do I want to move my vise? So right now the vise is kind of laying in the machine like this with the jaws coming normally. What I could do is hold it like that, so you're going to close on the vise jaws like here. We're only going to machine half of the slots and then we'll rotate the part. The other thing I could do is, again, the vise is kind of laying flat and it's normal, how you normally have a vise. We could rotate it on its side and so that the jaws are coming in from this side, and that would let us squeeze the part like this and get to the whole front face. We still have to flip it because the length of our we can't get all the way down with this arbor because it's not long enough, and that's okay. A longer arbor would too much risk of more run out or chatter and deflection. So we're going to try it without moving the vise. If it doesn't work, we'll move the vise. The way we're doing this is it's a 2D contour operation. I right click, edit. You can see 2D contour. Geometry that I'm picking is the top line, but then what I'm doing is I'm offsetting it by 1 thou more than the thickness of this blade, which drops the toolpath down appropriately. So 7 inches a minute at 400 RPMs, you can see it's a really, really small feed per tooth. Normally, like we talked about in the speeds and feeds videos, I don't like going less than half a thou, but this was working for us. The problem we have, or we got to be careful of, is the Tormach doesn't have full horsepower at the lower RPMs. It's got great horsepower for that machine at 2, 3, 4,000. Not so much even when we drop into the low belt at 400. We take a look at the simulation, oops, and scrub through it. You can see perfect. There's a little white gap right there, so in theory it's leaving us a little bit to clean up with the 1/8 inch end mill later, which is perfect. Goes across it. we have to do a second operation, which is the same thing, just duplicated it with the bottom chain selected, and that one, same thing. Instead of doing a positive for the bottom height to keep it off, I just did a positive 1 thou axial stock to leave. And if we simulate that, you can see again, it's a tapered fin here, but it's all still leaving a 1 thou right around in here. So then I do the same thing. This one, the first one and the last one are different because one of them is a straight walled thing and they're actually a different thickness gap. But I did the same thing for the first of the ones that we're going to pattern. So you can see that's going to cut this fin between here and here. So in the first and second, there we go, 1, 2. And then what you do, if you double click or if you select both of those, right click, choose add to pattern. That puts it in this pattern here, which is what's going to pattern that down. And if I edit that, you can see we picked the edge for the direction. And how did we get the 0.246 spacing? Hit I on your keyboard and click 2 known points. So that point I know and that point I know. And if you see that, you can see the distance here is 0.246. So that tells me that's the correct spacing. Kind of shows it right here too, but it's harder to see sometimes. So that patterns us down like so. So let's go make some chips.